This is Kevin Lewitsky. This is my submission for Lab 3, Intro to Logic Design. And for this lab, we had to use 2 3 to 8 decoders to create one 4 to 16 decoder. That's what these two chips are here. These are the 74138 chips. And then this is the 7420 chip over here, which is a 2 4-input NAND gate chip. So there's 2 NAND gates, each one has 4 inputs on that chip. These are the switches that I used here. I've got A, B, C, and D. And then these are my output LEDs. This one is X, and this one is Y. And for this particular lab, there's 2 equations, one for X and one for Y. And each one is a sum of product equation. And there's 4 terms in each equation. And then each term has A, B, and or C inputs. So we use the K-maps to expand those so that each term has all 4 inputs indicated, A, B, C, and D. And depending on whether those are on or off, if the switches are in the correct order that matches one of those terms, then that output LED will come on, and if it does not, then it would stay off. So what I'll do is I'll go through each equation. I'll go through the X equation first, and then I'll go through the Y equation. And what I'll do is I'll just put the switches in the combination that they're indicated in the equation to demonstrate that the LED light comes on. And when there's a don't care, what I'll do is I'll show that whether the switch is on or off, the light comes on for that particular term. So right now the power is on, and I'll turn all the switches off just to demonstrate that they're both off. And here both X and Y are off. So I'll do the X equation first. That's this LED here. For the first one, A is off, B, C, and D are on. And now A is off, B, C, and D are on, and the X light is illuminated. For the next one, A and C are off, B and D are on, and it's still on here. For the next one, A and D are on, B and C are off. And here A and D are on, B and C are off, and the X is on. And for the last one, for X, B, C, and D are all on. And here B, C, and D are all on. A is also on, X is on. When I turn A off, because A is a don't care, X still stays on. Now I'll go through the Y. For the first one, A, C, and D are on. Here A, C, and D are on, B is also on, Y is on. When I turn B off, B is a don't care, the Y still stays on. For the next one, A and B are on, C is off, D is on, D is a don't care, Y is still on. When I turn D off, since it's a don't care, the Y still stays on. For the next one, A, C, and D are on. Here A, C, and D as well as B are on, Y is on. Y is a don't care, I'm sorry, B is a don't care, so I'll turn B off and the Y still stays on. And finally, A, B, and D are all on, Y is on, and when I turn C off, C is a don't care, Y still stays on, A, B, and D are on. What I had to do, the way I have this set up, is A, B, and C switches go to their respective inputs on the decoder chips. So there's 2 wires coming from A, 2 wires coming from B, 2 wires coming from C. Each one goes to the A, B, and C inputs on those chips. And I had to go online to get the diagram for these chips to know for sure which pins correlate to the inputs, which ones are the enable pins, and which ones are the outputs. And then for D, since these are 3 to 8 decoders, they don't have a D input. So what you do is you use D to connect to one of the enable pins on each chip. And I have on this chip, it's connected to the enable pin without the inverter. And on this chip on the right, it's connected to the enable pin with the inverter. So what that means is when D is on, let me make sure I said that right. I have that backwards. D is connected to the enable pin without the inverter on this one, and on this chip it's connected to the enable pin with the inverter. So what that means is when D is on, this chip is on because there's no inverter, and this chip is off because it's connected to the one with the inverter. And when D is off, this chip is enabled and this chip is disabled. And then what you do is you just go through A, B, and C. A is equivalent to 1, B is equivalent to 2, and C is equivalent to 4. And so, for example, if you wanted the light to come on when B was on and A and C were off, B is equivalent to 2, so then you would just connect a wire from the number 2 output on the chip over to one of the inputs on the NAND gate. And then you have to know which chip you want to use based on whether D is on or off. And so that's how I have it set up here. And then it's 4 inputs for each NAND gate over here. And then one of the NAND gates is used for the X and one is used for the Y. That's it. Thank you.